Did you know Homeschool Pop has made a video filled with awesome science lessons?
I heard we're in it. Daniel is putting us right at the beginning.
That's right, my science friends. This video is absolutely packed with fun science lessons. I'm talking about clouds and how to identify them, the different types of rocks, the food chain, the sun, the moon, and more. It's going to be a blast. All right, to start this off, I want to admit something to you. I've been thinking about clouds a lot lately. I mean, they're pretty fascinating. They float along in the sky. Some days there aren't that many. Other days there are so many clouds, they actually block the sun from view. We are going to be learning all about clouds in this video. You'll learn what they are made of, what they do, how to identify different types of clouds, and more. Basically, after this video, you'll know a lot about clouds, okay? You'll understand them. You'll know, for example, that clouds are made of little drops of water or small pieces of ice, depending on the cloud. And that's our first fact. Clouds are made of little drops of water or small pieces of ice, depending on the cloud. So, when you see clouds in the sky, you can say, wow, look at that water up there. There's water up there just floating. And someone might say, you mean clouds, right? And then you could say, yeah, clouds are made of water. Okay, so clouds are made of water, but are there other things in clouds too, other than water? Yeah, there are. You see, clouds have other things in them called aerosols. That's an interesting word, aerosols. Okay, what in the world are aerosols? Well, aerosols are super tiny particles in the air. One common example of an aerosol is dust. This footage shows dust floating in the air. Are you able to see the dust? You might have to look closely. Like other aerosols, dust is so light it just floats in the air. Okay, this dog is kicking up a lot of dust. Dust is an aerosol and is found in many clouds. Who knows, Rover? Maybe the dust you are kicking up as you run may become part of a cartoon cloud someday. Who knows? Who knows? Another common aerosol in clouds is sea salt. Sea salt particles are very common in our atmosphere because 71% of our planet is covered in water. Okay, so aerosols are tiny little particles that float in the air like dust or sea salt. Now check this out. Water collects on the aerosols in the sky, forming a cloud. Aerosols are like floating hangout spots for the little drops of water that make up a cloud. It's like if this kid is a drop of water and the beanbag chair is an aerosol like a speck of dust. Water just hangs out on the aerosol particles, just relaxing. This is nice. Now, sometimes the water gets too heavy for the aerosol particles and falls out of the cloud to the ground. That's called precipitation. Precipitation. Big word. Can you say that? Precipitation. Yeah. Precipitation is a big word that refers to any time water falls out of clouds to the ground. What type of precipitation is this? Yeah, rain. Rain is a great example of precipitation. When it's raining, it's like the clouds in the sky are sharing their water with us. Wow, look at all of the water the clouds are sharing with us. Thanks. Oh, hey, maybe a little too much rain, you think? You can keep some of the water for yourselves, clouds. Another form of precipitation you may have seen is snow. Snow. Does it snow where you live? Okay. If it's cold enough, snow can fall from clouds. There are other types of precipitation too, like freezing rain, sleet, and hail. They are all ways that water falls from clouds to the ground. That is a big part of what clouds do. But that's not all. Clouds also lower the temperature, cooling the Earth. Some of the sunlight bounces off of clouds, making it less hot. First, they share their water with us, and then they help us stay cooler. Wow. Dear clouds, thank you for the water you bring to us through precipitation and for making it cooler here. I also want to say I'd love a pony. I don't know if you grant wishes. I just thought I'd try. Sincerely, Homeschool Pop. Oh, now it's time for a random cloud fact. This is a cloud fact you can be sure is a fact about clouds. All right, here we go. Some clouds can move faster than 100 miles per hour. Woo-hoo-hoo-hoo. Those are the fastest clouds. Most clouds move slower than that, but the fastest clouds can move over 100 miles per hour. That's really, really fast, especially since clouds are made of water, That's fast water. Fast water. Aw, Pupsy wants to race the clouds. You're fast, Pupsy, but are you cloud fast? Hey, Pupsy, while you run, let's look at a random cloud fact. Again, another one, another cloud fact. You keep running. All right, this might come as a surprise, but fog when it's hard to see outside and it kind of looks like clouds are floating around on the ground? Well, fog is a type of cloud that touches Earth's surface. Fog is a type of cloud. If you've ever wished you could touch a cloud, just wait for a foggy day. Dream come true. Look at that fog just floating there. Fog is a type of cloud that touches Earth's surface. Okay, is anything going to jump out of the water, or are we going to see anything interesting, or are we just staring at the fog here? I guess it's just the fog. That's okay. All right. Okay, now we are going to learn about 3 types of clouds, so you can identify clouds in the sky the next time you're outside. First, we have cumulus clouds. Cumulus clouds. Cumulus clouds are like pillows in the sky. They look super fluffy. They look like clouds you would just want to hug. Cumulus clouds. Next, we have stratus clouds. Stratus clouds are like blankets in the sky. They look really flat. Stratus clouds are flat clouds that are almost like blankets. Stratus. Last, we have cirrus clouds. Cirrus clouds look very wispy. Cirrus clouds almost look like white cotton candy strands. Sometimes they can almost look like feathers. Cirrus clouds. Let's see, cumulus clouds are fluffy, stratus clouds are flat, cirrus clouds are wispy. What do you think of that? Oh wow, that rhymed. That's cool. Hey, what type of clouds are these? They look flat, almost like blankets. Yeah, stratus. These are stratus clouds. Great job. All right, what type of clouds are these? They look fluffy like pillows. Yes, cumulus. These are cumulus clouds. Finally, what type of clouds are these? They look wispy, like cotton candy strands or feathers. Cirrus. These are cirrus clouds. Awesome job. There you have it, clouds. You know they're made of water, you know they have aerosols in them, you know they can bring precipitation and lower the temperature. Some of them move as fast as 100 miles per hour. You know 3 types of clouds. You did great. You did a great job. Okay, guess what we're learning about next? Yeah, rocks. We're going to learn about rocks. Rocks are all around us. You see rocks all the time, and some rocks are huge, like the rocks that make up this massive rock formation. They're huge, but then sometimes rocks can be really tiny, wee tiny little baby rocks. Rocks are amazing, and they're all around us. So what are rocks? Well, rocks are solid chunks of one or more minerals. Rocks are mineral chunks. They're solid chunks of one or more minerals. Now, most rocks are mixtures of multiple minerals, like these rocks. Other rocks are made up of just one mineral. Like in this picture, this is a picture of chalk. Chalk is a type of rock made of a mineral called calcite. The next time you play with chalk, just think, wow, this is made of calcite. These are like sticks of calcite. Chalk is a rock that's made of calcite. So, rocks are solid chunks of one or more minerals, and they are super fun to learn about. That's why geologists are so cool. Geologists are rock experts. They study rocks as their job. Geologists disagree about how many different types of rocks there are, but we can all agree on this. There are so many different types of rocks. To make things more simple, rocks are put into three categories, three major types of rock: sedimentary, igneous, and metamorphic. Can you say those with us? Sedimentary, igneous, and metamorphic. Yeah. Now this is pretty interesting. The category that a rock belongs to tells us how that rock was made. Here, we'll show you with our first category of rocks, sedimentary rocks. Alright, so what are sedimentary rocks? Sedimentary rocks are rocks that are made up of little particles. They're made up of little particles. The particles are called sediment. Can you say that with us? Sediment. Yeah, sediment. An example of sediment is sand. Yeah, sand is a type of sediment. It's kind of cool. Seashells are an example of sediment as well. So there are lots of different types of sediment, but they're particles. They could come from non-living things like sand, or they could come from living things like seashells. That's fun. Sedimentary rocks are made up of little particles called sediments. And you can even tell that from the name, sedimentary. Sediment is in the name. So if you forget, just look at the name. Sedimentary. Sediment is in the name. So the way sedimentary rocks are formed is by sediments collecting at the bottom of bodies of water like lakes and oceans. The sediment is pushed down by the water, and over time, the sediment starts to harden into rock. Water is what really makes sedimentary rocks. Without the water, the sediments would never harden to become sedimentary rocks. They need water. Just think, in that water right now, sediments are getting pressed down and are hardening to become rock. The molecules in the water help the sediment stick together, kind of like cement. That is how sedimentary rocks are made. Okay, we have two categories left. Let's learn about metamorphic rocks next. Metamorphic rocks are made when a rock goes through a lot of heat or pressure. Remember, sedimentary rocks need water to be formed. They need water. Metamorphic rocks are different. Metamorphic rocks are rocks that need heat or pressure to be formed. Here's a simple way to remember that. The word metamorphic has another word inside of it, the word morph. That's interesting. The word morph means to be changed. So, when you think of rocks that are changed by heat or pressure, think metamorphic. Metamorphic rocks morph. They are changed by heat or pressure. Metamorphic rocks are formed below the Earth's surface. That's cool. And here's the thing, okay? They make up a lot of the Earth's crust, which is the outer shell of the Earth. Much of the Earth's crust is made of metamorphic rocks. So we're not talking about this type of crust. We're talking about the Earth's crust, okay? You can see that the Earth's crust, the outer shell of the Earth, is broken up into these things that almost look like puzzle pieces. Scientists call these plates. Here is a map of these plates, okay? And they have a really cool name. Scientists call them tectonic plates. Can you say that with us? That's so cool. Tectonic plates. These huge plates move and push against each other. And there is a lot of heat and pressure there. Oh. That's why there are so many metamorphic rocks that form in and around the Earth's crust. Wow. Mystery solved! And this is cool. The heat and pressure not only change what the rock looks like on the outside, they change what the minerals themselves are like, so the rock actually changes form. That means the heat or pressure morphed the old rock into a new rock, a metamorphic rock. Now, sometimes sedimentary rocks get pushed into the earth and are around pressure or heat. Then the sedimentary rock turns into a metamorphic rock. It morphs or changes into a different rock. It has become metamorphic. So, heat or pressure create metamorphic rocks, and they usually form deep under the surface of the earth, in and around the earth's crust. Alright, now we've come to our final rock category, igneous. This is really interesting. Igneous rocks are formed when molten rock cools and hardens. You might be wondering, what does molten rock mean? What is molten rock? Well, this is molten rock. Molten rock is liquid rock, and there's two forms of it. Inside of the earth, molten rock is called magma. That's right, magma. But when it comes out from inside the earth, it is called lava. Lava is molten rock too. Lava is molten rock that is no longer inside of the earth. So igneous rocks are formed when molten rock cools, and that molten rock can be magma or lava. Do you remember how metamorphic rocks are formed from pressure or heat? Well, igneous rocks are kind of the opposite, aren't they? Igneous rocks are formed from molten rock cooling. Isn't that interesting? Metamorphic rocks are formed from pressure or heat, and the igneous rocks are formed during this cooling of molten rock. Sometimes metamorphic rocks are heated so much they turn into molten rock. When this molten rock cools, it becomes an igneous rock. That's pretty cool. A common place for igneous rocks to form is a volcano. The lava that erupts out of a volcano cools, but the magma below a volcano can cool as well, forming igneous rocks. Remember, rocks are chunks of minerals. They are mineral chunks, and they are grouped into 3 different categories. The first category was sedimentary. Sedimentary rocks are formed when particles called sediments join together. It is almost like they want to be friends as they form a new rock. The second category was metamorphic. Metamorphic rocks are formed from heat or pressure. It is almost like when someone gets angry, their face, actions, or words can be changed or morphed. Finally, the third category was igneous. Igneous rocks are formed when molten rock cools off. This molten rock can be either magma or lava. Igneous rocks are like when someone was really angry but decides to take deep breaths to start to cool off. Igneous rocks are formed when molten rock chills out. We've talked a little bit about this as we've learned about these types of rocks, but rocks change. Scientists call it the rock cycle. Igneous rocks can break apart into sediment and become sedimentary rocks. Sedimentary rocks can be pushed into the earth and become metamorphic rock. And metamorphic rocks can turn into liquid rock and cool into igneous rock. That's amazing, isn't it? That is called the rock cycle. It's fun to learn about rocks. Next time you find a rock, find out what type it is and think about all that rock has gone through. Rocks aren't just chunks of minerals. They tell a wonderful story about how the earth works. You did an incredible job learning about rocks. Wow. All right. Next, we're going to turn our attention to food. That's right. Food. Food is super important. Super important. It's a big part of your day, right? You need food to live, right? It's very important. You know, if you've seen many of our videos, that we love carrots. Carrots are a great example of a food that can give us lots of energy, that can help us through the day. Food isn't just for people. Here's a dog eating a treat. That looks yummy, for a dog. Fish have to eat, and so do bears. Look at this bear eating berries. It's kind of funny, a bear eating berries. That's only kind of funny. Enjoy your berries, Mr. Bear. Sorry, it's, enjoy. Keep eating, keep eating. Did you know even plants like trees need food? Did you know that? Isn't that cool? In fact, all living things need food. All living things need food. But how do they get that food? That's a good question. That's what this video is all about. To find out how living things get food, you will be learning about something called the food chain. Can you say that with us? The food chain. Yes, the food chain. Now, a food chain isn't an actual chain of food, like a long chain of carrots, okay? That's not what the food chain is, even though that would be really cool. The food chain explains how living things get the food they need. The food chain. There are different parts of the food chain. We are going to learn about the different parts of the food chain to see how living things get food. First, we are going to learn about producers. Producers make up the first part of the food chain. Producers are living things that make their own food. If a living thing creates its own food, it is a producer. We are surrounded by producers everywhere we go because every plant is a producer. Yep. Every plant in the entire world is a producer. That grass, it's a producer. It makes its own food. Those trees, they are producers. They make their own food. These flowers, they are producers. They make their own food. Now wait, how can plants make their own food? You never see a plant in the kitchen saying, "Hey, I'm gonna cook something real fast. I need to make some of my own food. So, can you tell me where the pans are?" No, plants make their own food through a process called photosynthesis. Wow, that's a big word. Photosynthesis. Photosynthesis is amazing. Plants use energy from the sun to make their own food. That's why plants need sunlight. So plants make their own food, but they don't cook or bake. They get energy from the sun to make their own food. Photosynthesis. You know, that's one of the reasons you'll never see plants shopping for groceries to get food. You'd have to tell the plant, hey, don't you use energy from the sun to make your own food using photosynthesis? It's nice to meet you and everything, but you need to make your own food, using sunlight, water, and air. You're a producer. So, when the sun is shining on plants, just think of how the sunlight is helping the plants make their own food using photosynthesis. That is how plants are producers. They make their own food. Producers make their own food. Okay, pull it together. All right, let's cut off the sad music. There's nothing sad about photosynthesis or sunlight. Okay. Where were we? Oh yeah, it's time to see the next part of the food chain. Consumers. Consumers. Now, consumers have to look outside of themselves for food. They cannot create their own food using photosynthesis as producers can. As you might have guessed, we humans are consumers. We don't make our own food using photosynthesis. Now, there are farmers who grow food, cooks who make different foods, but we are all consumers. We didn't make our own food within ourselves. We eat the foods in our environment or around us that help us stay healthy and strong. And we aren't alone. Fish are consumers. Cats are consumers. Birds are consumers. Animals are consumers. It's interesting, there are different types of consumers. There are herbivores, which are consumers that eat only plants. There are carnivores, which are consumers that only eat meat. And there are omnivores that eat a combination of plants and meat. Okay, let's see if we can remember this. All right. So, herbivores stick to plants. That's what they eat. Carnivores eat meat, and omnivores eat a combination. This will be fun. Can you guess what type of consumer a gorilla is? What type of consumer is a gorilla? Yeah, gorillas are herbivores. They eat only plants. They love eating plants with leaves and enjoy bamboo as well. Gorillas are herbivores. They eat only plants. All right, can you guess what type of consumer a frog is? What type of consumer is a frog? Frogs are carnivores, yeah. They only eat meat. They love eating insects, worms, and if they are big, they can eat bigger creatures like mice, small snakes, and more. Frogs are carnivores. They eat only meat. Hey, what about us humans? We are considered omnivores. That means we have the ability to eat a combination of plants and meat. Just because we can eat a combination of the two doesn't mean we have to, though. Many people around the world only eat plants. Many others around the world eat a combination of the two. But because we have the ability to eat both, scientists consider us omnivores. Remember the bear from the beginning? Bears are omnivores too. They like eating berries, but they also can eat meat. They eat a combination of plants and meat. They're omnivores. Okay, now we have come to a very interesting part of the food chain. Decomposers. Decomposers, can you say that with us? Decomposers. That's right. This might sound weird, but decomposers are living things that take apart dead animals. That's right, they take apart dead animals. Decomposers have a very important job. They break down dead animals so that plants can get more nutrients from the soil. Some examples of decomposers are fungi, worms, and snails. But how do they take apart dead animals? Well, decomposers like to eat dead things. In the case of fungi, they release stuff called enzymes, which break down dead matter, and then the fungi takes in the nutrients. You've probably seen fungi before. Did you know that mushrooms are fungi? That's right. Oh no, that reminds me of a joke. Can I tell the joke? I don't know if I can resist. That mushroom sure looks like a fun guy. I get it, because mushrooms are fungi. Feel free to share it with your friends. It's comedy gold. So, decomposers break down dead animals, which helps the soil. The better soil helps the producers, which are plants. Then consumers eat the producers, other consumers, or both, depending on what type of consumer they are. Then, after the consumers die, the decomposers break them down to help the soil. And it starts all over again. It's like this chain. It's the food chain. Remember, the parts of the food chain are producers, consumers, and decomposers. All living things need food, and every living thing has its place in the food chain. Producers make their own food using photosynthesis. Consumers can't make their own food. They eat plants or meat, or both, depending on what kind of consumer they are. And decomposers eat dead animals, bringing nutrients to the soil to help the producers. What a chain! The food chain.
Awesome! You did great! The food chain is pretty cool, you know? All right. Now we're going to switch it up a little bit and look beyond our planet. That's because next,
we are going to learn about a massive star in the center of our solar system. What is it called? Yeah, the sun. Actually, the sun is the only star in our solar system, but still, it is huge, it is bright, and without it, life on Earth wouldn't exist, so it is super important. But let's start here. The first fact about the sun we want to learn is that the sun is just a regular star. That's right, it's just a regular star. There are hundreds of billions of stars in our galaxy called the Milky Way galaxy. But the sun is special to us, right? Because it is in the center of our solar system, but the sun really is a regular star. Like other stars, the sun uses hydrogen to burn bright. Hydrogen is the sun's fuel, just like food is our fuel and gasoline is the fuel used by cars. The sun uses hydrogen as fuel. If you're wondering what hydrogen is a gas found all over our universe. And it's hard to see because it doesn't have any color to it. But it's all over the place. In fact, hydrogen is the most common element in our universe. So stars use a gas called hydrogen as fuel. The larger the star, the faster it burns through hydrogen. Thankfully, the sun has at least a 5 billion year supply of hydrogen left. So the sun will keep burning for a long time. Here's an interesting question. How far is Earth from the sun? How far is our planet from this huge star in the center of our solar system? Well, it's pretty far away. The sun is about 93 million miles away from Earth. That's right, about 93 million miles away from our planet, Earth. And it's a good thing. It's a great thing that the sun is about 93 million miles away, because if we were any closer to the sun, it would be way too hot to sustain life. And if we were further away, we would all freeze. It would be way too cold. So the sun is the perfect distance away from the Earth. Of course, having a huge star 93 million miles away helps us to see things, right? It is helpful to have a massive burning light in the middle of our solar system that runs on hydrogen. I mean, can you imagine living in a world without light? It would be like this. This is what our world would be like without sunlight. It would just be dark. You know, we wouldn't be able to see anything. We'd be like bumping into each other and it'd be crazy. We'd be like, oh, wow, is that a mountain or is that a chicken? Or what's going on? Where am I? What's going on?
The sunlight allows our eyes to see what's going on around us. But the sun provides more than just sunlight. The sun provides energy. One powerful way the sun provides energy is through a process called photosynthesis. Wow, that's a big word. Can you say that with us? Photosynthesis. Yeah, photosynthesis. Photosynthesis is how plants make plant food and produce oxygen. Without sunlight, plants cannot make plant food or release oxygen. You know, plants are not alone in using sunlight for energy. We use sunlight for energy as well. The energy we get from sunlight is called solar energy. Just like plants capture sunlight in the process of photosynthesis, people capture sunlight using these things called solar panels. Isn't that cool? Here are two men installing solar panels. The sun is powerful. It is awesome to see how we can use some of its energy to get power and electricity. It has been so much fun learning about the sun with you. We learned that the sun is the only star in our solar system. Do you remember where in our solar system the sun is? Right in the middle. Yeah. Like other stars, it uses hydrogen as fuel. Thankfully, it has a lot of hydrogen, so it will keep burning and burning for a long time. We learned that the sun is about 93 million miles away, which is actually the perfect distance. If the sun was further away, it would be too cold. If it was closer, this planet would be way too hot. We also learned that the sun not only provides light, it brings energy. Plants use energy from the sun in a process called photosynthesis, and people get energy from the sun using things like solar panels. Energy from the sun is called solar energy. The sun, a regular star, but it is special to us. It's our star.
That was cool. How are you doing? If you need to, you can take a moment and stretch or dance, whatever. That's right. All right. I think it's time. You just finished learning about the sun, you know. There's something else we should probably learn about next. When you go to sleep at night, resting well after another exciting day, there is this bright, amazing thing in the sky. It looks a lot bigger to us than the stars and is almost like Earth's nightlight. We are going to learn about that incredible thing that we see at night called the moon. We call it the moon because it is our moon. Earth only has one moon, which is different than many other planets. In our solar system alone, there are over 200 moons. Isn't that incredible? In our solar system alone, there are over 200 moons. But out of all these moons, our moon is the most special to us, and we hope you'll see just how awesome it truly is as we learn about our little friend in the solar system, the moon. It's interesting. The moon really is our little friend in the solar system. The moon is always there for us, and we are always there for the moon. Love you, buddy. You see, the moon orbits Earth, meaning it goes around and around our planet. It's almost like the moon is playing a game with the Earth. It's almost like a carousel going around and around and around. The moon continually orbits Earth. Things that orbit our planet, that go around and around and around the Earth, are called satellites. Satellites. Anything that orbits our planet is a satellite. The moon is a natural satellite. It's an object we did not create that orbits our planet. The moon is a natural satellite. Isn't that cool? Here is an example of an artificial satellite. It is something people made that orbits Earth. They cost hundreds of millions of dollars to make and can do all kinds of awesome things in space. But this video isn't about artificial satellites, right?
It's about Earth's largest natural satellite. Yeah, the moon! The moon is the Earth's largest natural satellite. Here is another interesting fact about the moon. The moon is made of rock and metal, just like the Earth is. That's right. The moon is made of rock and metal. You may have heard someone say that the moon is made up of something else, something more silly. For hundreds of years, people have joked that the moon is made of cheese, but that's just a funny, silly thing people have joked about. And even if it was made of cheese, what if it went bad? Eek, the smell. How would you feel if the moon was made of cheese? Okay. So the moon isn't made of cheese. The moon is made of rock and metal, just like the Earth is. Hey, would you like to find out just how fast the moon is moving right now? Because the moon is always orbiting Earth. But how fast? Check this out. The moon goes over 1 mile every 2 seconds. That's over half a mile a second. That's crazy fast. The moon, this massive natural satellite made of rock and metal, is going over 1 mile every 2 seconds. Let's count. 1, 2, another mile. Hey, another one. The moon is moving so fast, it only takes about 27 days for the moon to completely orbit Earth. Woo! Don't get in the moon's way, right? We've learned so much already. Let's review what we've learned about the moon. Okay, that's definitely a fake shooting star. Did we really need to add that? It did look cool, though. There are over 200 moons in our solar system. Earth only has 1 moon. We call it the moon, which makes sense. The moon is a natural satellite. Satellites are things that orbit Earth. It orbits pretty quickly. The moon goes 1 mile every 2 seconds. Okay, stop the music. Stop the music. We're all gonna go to sleep with this music on. We need something more upbeat. We're talking about how fast the moon is. It's cool. It's exciting, okay? Yes, this is more like it. Let's talk about how fast the moon is again, but with this fancy music. The moon goes 1 mile every 2 seconds. The moon is so fast, it only takes about 27 days for the moon to completely orbit Earth. Wow. And we learned, like the Earth, the moon is made of rock and metal. That'll work. Wow, what a review. What a review. All right, now it's time to solve a mystery. Are you ready? Okay, so let's look at this footage. What color is the moon? Yeah, it's like this yellowish color. Now look at this footage. It's white, but then it kind of turns gray and then white again and gray. It's like this whitish gray. Same moon, right? Same moon, different colors though. Well, one thing's for sure. The moon itself doesn't change color. The moon is always gray. When Neil Armstrong became the first person to walk on the moon, it was gray. It is still gray. The moon itself doesn't change color. So why does the moon appear in different colors to us here on Earth? The biggest reason is because of our atmosphere, which is made up of all of the gases that surround our planet. When we look into space, we are looking through all of the surrounding gases, which can change what things look like. That's why the moon can look like it is changing colors to us. Okay, now we come to a very important fact about the moon. The moon doesn't make its own light, it reflects the light of the sun. Let's say that again. The moon doesn't make its own light, it reflects the light of the sun. This makes sense because remember, the moon is made of rock and metal, which aren't able to produce their own light. No one picks up a rock and says, "Woohoo, I'm gonna use this as a flashlight," because the rock doesn't make light. But that same rock, if the light shining on it is bright enough, will reflect light. That's what the moon does. The moon reflects the light from the sun. Now this is cool. Have you ever wondered why sometimes the moon is a full circle and sometimes it's almost like it isn't even there? It's like the amount of light the moon is reflecting changes. Well, we would like to show you the 8 phases of the moon. These phases are the reason the moon can look different throughout the month. 8 phases. How can we remember that the moon has 8 phases? The moon has 8 phases. Okay. It takes a month for the moon to go through all 8 phases, and then it starts all over again. So in a month's time, you can see all 8 phases of the moon. Wow, the moon is a natural satellite made of rock and metal that completely orbits Earth every 27 days. It doesn't make light, but reflects the light of the sun. How much light the moon reflects can change depending on what phase it is in. There are 8 phases of the moon. It takes the moon a month to go through all 8 phases. And if you ever look into the sky and see a red moon or a yellow moon, remember our atmosphere can change the appearance of the moon, but the moon itself never changes color. It is always gray. Well, that's our little friend in the solar system, the moon. There are over 200 moons in our solar system, but the moon is ours. We'll see you tonight, buddy.
All right, let's take some time to learn the 8 phases of the moon. We'll learn all 8 of them. You know, sometimes the moon looks like this, and you might think, hey, that's just what the moon looks like. But other times, the moon might look like a complete circle. Well, as we just learned, that's because the moon goes through phases. The phases of the moon change what the moon looks like to us here on Earth. Here are the phases of the moon. If you count them, you'll see there are 8 phases of the moon. These are the phases of the moon. Notice in one phase, you don't see the moon at all, and in another phase, you can see the entire moon. So these 8 phases have a big impact on what the moon looks like to us. Soon, you'll know all 8 of them. All right, let's jump right in and learn these phases of the moon. Starting with the first phase of the moon, it's called a new moon. If you're wondering where it is, join the club. It's actually right here where the arrow is pointing. And notice you can't see a new moon. That's right, it looks like it just isn't there. So why can't we see a new moon? Well, during a new moon, the moon is in between the sun and the earth. Because of this, it can't reflect the sun's light toward us. So during a new moon, we can't really see the moon. That's pretty interesting. Now, after a new moon, the moon starts waxing. What? Yeah, waxing. What is that supposed to mean? Well, waxing means growing. When the moon is waxing, it is getting bigger. Notice the moon begins waxing after a new moon and grows until it becomes a full moon. Waxing means growing. After a new moon, the moon continues waxing until it becomes a full moon. Just remember, waxing means growing. All right, we're ready for phase number 2. And look at this number 2, so cool, so icy, so awesome. The second phase of the moon is called a waxing crescent. A waxing crescent. That's an interesting name for this. A waxing crescent. Waxing, of course, means that it is growing bigger, and it is called a crescent moon because less than half of the moon looks lit. If you live in the northern hemisphere, the part of the world that is north of the equator, a waxing crescent is always lit on the right side. Hey, check this out. Here is a photo of a waxing crescent.
Less than half of the moon looks lit. If you live in the northern hemisphere, north of the equator, a waxing crescent is always lit on the right side. This crescent moon is waxing because it is growing. This is the phase of the moon after a new moon. Waxing crescent. Okay, you are ready for phase number 3. That's right. The third phase of the moon is called first quarter. First quarter. Which at first might seem a little weird. See, the moon is half lit with a first quarter moon. So what's the deal? Shouldn't first quarter be called 1/2 moon? Well, when you have a first quarter moon, you are 1/4 or 1/4 of the way through the lunar cycle. You can see all 8 phases of the moon here. A first quarter moon tells you that you are a quarter of the way through all 8 phases. So a first quarter moon is half lit, and because the moon is still waxing or growing, in the northern hemisphere the right side is lit. Exactly 1/2 of a first quarter moon is lit, and it is lit on the right side because it is waxing. All right, we are ready for the next phase. The next phase is called the waxing gibbous. Waxing gibbous. Wow. Weird name. A waxing gibbous is more than half lit, but not quite fully lit. It is the 4th phase of the moon. A waxing gibbous is more than half lit and, like all of the waxing moons, is lit on the right side. Here is a photograph of a waxing gibbous. Can you say that with me? Waxing gibbous. Softer. Waxing gibbous. Finally, let's say it so everyone can hear it. Waxing gibbous. Great. The cool thing about a waxing gibbous moon is that when you see it, you know a full moon is on its way. And sure enough, phase number 5 is... Wait, Mr. Whiskers, you need to eat right now? Mr. Whiskers, this is not a convenient time. We're about to talk about a full moon and everything. Okay, I understand. No kitties should wait. All right, there you go. Now, where were we? Oh, yes. Phase number 5 of the moon. Enjoy, Mr. Whiskers. Phase number 5. The 5th phase is a full moon. It is the easiest phase to spot. A full moon is completely lit. It is a full circle. Is there anything else to say about it? It's full, it's a full moon, and once the moon is full, it is all done waxing because it can't grow anymore. It's done waxing. Which means it will look like the moon is getting smaller and smaller. The fancy moon word for that is waning. Waning. That's an interesting word. Waning. The moon always begins waning after a full moon. But just like waxing, waning is a process. It doesn't happen all at once. Okay, so the moon begins waning after a full moon. It starts waning, appearing smaller and smaller until finally you can't even see it anymore. When you can't see the moon, remember, that is a new moon. The first phase we talked about. Waning starts with a full moon and ends with a new moon. When the moon is waning, it looks like it is getting smaller and smaller. Now, after a full moon, we have phase number 6, a waning gibbous. Wow, a waning gibbous. As you can see, a waning gibbous is similar to a waxing gibbous, except instead of getting bigger every day, it is waning or getting smaller. A waning gibbous is more than half lit, and in the northern hemisphere, it is lit on the left side instead of the right side. That tells you that this is a waning gibbous. It is getting smaller and smaller. Next, we have the 7th phase of the moon. You know, the easiest way to learn the 7th phase might be to look at it with the other phases. Here are all 8 phases of the moon. The 7th phase is right here. It is called the last quarter. The last quarter means you only have a quarter of the lunar cycle left. A quarter means 1/4. You are in the last quarter of the lunar cycle when you have a last quarter moon, so that name makes sense. Just like a first quarter moon, a last quarter moon is half lit. But because the moon is waning during a last quarter moon, the moon is lit on the left side. Quarter moons are always half lit. If you live in the northern hemisphere, the last quarter is always lit on the left side. Well, the moon has been waning, getting smaller and smaller. There's only one more phase before we start the cycle all over again. That's right, we are on phase number 8. The last phase of the moon is a waning crescent. A waning crescent. A waning crescent is less than half lit. All crescent moons are less than half lit. To figure out if a crescent moon is a waning or waxing crescent moon, just look at the side it is lit on. Waning moons are always lit on the left side, so a waning crescent is less than half lit and is lit on the left side like you see right here. Those are all 8 phases of the moon. Pretty cool. If you have a favorite, you won't have to wait long before you see it because it only takes a month for the moon to go through all 8 phases. That means all of this just takes 1 month. That's pretty awesome. That's pretty cool. All right, you know what? It's time for a game. We're going to see how much we learned about the phases of the moon. Let's call it the Phases of the Moon game. Yeah, that's a good name for it. Are you ready to play? Okay. Ooh, fancy music. We'll go in order just like in nature. What is this phase called? Yes, a new moon. Fantastic. And of course, you can't see a new moon. It's like it's hiding. What is this phase called? A waxing crescent. Crescent moons are less than half lit, and this moon is lit on the right side, so it must be a waxing crescent. Great job. What is this phase called? It's half lit. Yeah, first quarter. This is a first quarter moon. Very cool. How about this moon? What is this phase called? A waxing gibbous. A waxing gibbous, yep. A gibbous moon is more than half lit, but is not quite full yet. And we know it is a waxing gibbous because it is lit on the right side. Great. What is this next phase? What is it called? You got it, a full moon. A full moon is easy to spot in the night sky. It is completely lit. A full moon. You are doing awesome. How about this next phase? What is this phase? A waning gibbous. That's right, a waning gibbous. After a full moon, the moon begins waning or getting smaller. A waning gibbous is more than half lit, just like a waxing gibbous, but is lit on the left side. You are doing a tremendous job. Let's try this one. What is this phase called? Do you remember? Yeah, last quarter. This is a last quarter moon. It is half lit and begins the last quarter of the lunar cycle. A last quarter moon. How about this last one? What is this phase called? Great! A waning crescent. A waning crescent. It is less than half lit, which is what makes it a crescent moon, and it is lit on the left side, so it is waning. Every month, the moon goes through all of the phases. The moon goes around and around, waxing and waning. It's pretty amazing. Well, you know all 8 phases of the moon. Tell your friends. Tell a dog. Tell a cat. Tell a hamster. Whatever. Just tell someone. Because that's pretty cool. It's pretty cool that you know all 8 phases of the moon. You've done amazing. You just finished learning all 8 phases of the moon. And now there's just one more science lesson left in this video. Wait, I'm seeing something interesting here. Oh my goodness, it's a robot dog. Literally. I mean, it's strange. This is a robot dog. It's a dog robot. This robot acts like a dog, moves on its own like a dog. It's kind of cool. This is a robot that cleans floors. Maybe you've seen one of these before, or maybe there's one in your house. Robots are pretty interesting because they move on their own, but they aren't alive. They aren't living, which has me thinking, okay, what makes something alive? How do we know the difference between living and non-living things? Well, there are a few things to think about when we try to figure out if something is a living or a non-living thing. And the first thing to think about is water. That's right, water. Hang on, what does water have to do with living and non-living things? Why are we thinking about water? There's a simple reason why. You see, all living things need water. All living things need water. Did you like my robot voice? For example, grass needs water. Like all plants, grass is a living thing and needs water to survive. This boy is giving the grass the water it needs and is having fun at the same time. Here's another example. Dogs need water. Like all animals, dogs are living things and need water to survive. Cute dog. Yeah, I don't see a robot dog drinking water. Interesting. It seems our robot friend is a non-living thing. Didn't pass the water test. The next thing we want to think about when figuring out if something is living or non-living is how or if it changes over time. That's because all living things develop and grow. All living things develop and grow just like with this plant. It develops from a tiny little sapling, a little baby plant, into a mature plant. You can see how it grows. It gets bigger and stronger. Like all living things, this plant develops and grows over time. Watch this plant grow. It's so awesome. Plants really are living things. Now, it doesn't happen this fast. This is sped up so we can see it grow, but it's so cool. Here, we can see elephants of different sizes. Like all living things, elephants grow. Little elephants grow up to be big elephants. Living things grow. The final thing we want to think about when we're trying to figure out if something is living or non-living is if it needs food. Remember how living things grow? Well, living things need food to do that growing. All living things need food. If you've watched many Homeschool Pop videos, you know how much I love carrots. I think of carrots when I think of food. Here's a picture of the sun. Why do you think the sun is pictured when we talk about food? Do you know? Plants use sunlight to make their own food. Wow, it's called photosynthesis. Can you say that with me? Photosynthesis. Yeah, can we say it like a robot? Photosynthesis. Photosynthesis is how plants use sunlight to make their own food. They literally make their own food using sunlight. So for us, food looks very different than it does for plants. Plants make their own food using sunlight, and that's called photosynthesis. Food is different for another type of living thing called fungi. Fungi. Mushrooms are a type of fungi. Mold is a type of fungi. Ugh. Mold. Ugh. Fungi are living things. They need water, they grow, and they need food. But they have a strange way of getting that food. You see, fungi absorb their food. They don't eat like we do or make their own food like plants do. They just absorb it. Wouldn't it be weird if we absorbed food like fungi do? That would be strange. That would be very, very strange. Hey, let's go over the clues again. The clues to figure out if something is a living or non-living thing. First, living things need water. Water. Second, living things grow. They go from being tiny to full grown. They develop over time. Third, living things need food. We talked about how living things can have different ways of getting that food, either through eating like we do, using sunlight to make food like plants do, or absorbing food like fungi. But all living things need food. All right, I think it's time to practice using these clues. Okay. Is this bird living or non-living? Is this bird living or non-living? Yeah, living. We know this bird is living instead of non-living because this bird needs water, this bird grows, and this bird needs food. Great. Let's try this one next. Is this balloon living or non-living? Is this balloon living or non-living? Yeah, non-living. While the balloon grows and gets bigger when you blow it up with air, it doesn't need water to survive and it doesn't need food. You need all three clues for something to be a living thing. A balloon is a non-living thing. Awesome job. What about this palm tree? Is this a living or non-living thing? Living. Trees, just like other plants, need water, grow, and need food. Awesome job. Here's our last one. Is this globe living or non-living? Is this globe living or non-living? Yeah, non-living. It doesn't need water to survive, it doesn't grow, and it doesn't need food. A globe is a non-living thing. If something needs water, grows, and needs food, it's living. Yeah, it's a living thing. If something needs water, grows, and needs food, it's living. Yeah, it's a living thing. I think you're ready. You know all the clues. Now you can explain exactly how this robot dog is not a living thing, even though it moves on its own. It doesn't pass the test. But mold does. Wow, I'm sorry. That's weird. It's weird that mold is a living thing. I don't like that. Not one bit. I don't like it. Oh my goodness, you are a science champ. You learned so much in this video and you made it to the end. You are so awesome. If you haven't subscribed and you thought this was cool, consider clicking the subscribe button. Thank you to my patrons and thank you for hanging out with me and learning. I had a blast. I hope you did too. And I will see you next video.